Good morning. I'm Dr. Amina Priyadarshini. In today's class, we shall discuss about the digital modulation scheme. The first one is the binary phase shift keying. So binary phase shift keying, it is named as BPSK. So here, the modulator has two inputs. One is the message and one is the carrier. The message will be a digital data, so it is binary ones and zeros, and the carrier will be a continuous time signal. Here we have considered the sinusoidal signal. So first of all, the output of the modulator, it will produce the signal accordingly based on the input signal. That is, if this for symbol 1, it is indicated by one phase, and the symbol 0 is indicated by another one phase. So let us consider a pair of signal S1 of t and S2 of t that are used to represent the symbol 1 and 0. Symbol 1 is indicated by square root of 2 EB by TB cos 2 pi FCT, and symbol 0 is indicated by that is 180 degree phase shifted version of symbol 1, therefore the minus sign is there. So minus square root of 2 EB by TB cos 2 pi FCT, where EB is the energy of the transmitted signal and TB is the bit duration, and therefore it has the property that the transmitted energy per bit EB is constant. Equivalently, the average transmitted power is constant. And demodulation of BPSK cannot be performed using envelope detector like the amplitude modulator. We have to look at the coherent detection schemes. So this is the waveform for BPSK signal. The input is symbol ones and zeros. The symbol 1 is indicated by 1 volt signal and symbol 0 is indicated by 0 volt signal. So for the duration where the symbol 1 is present, the signal there is no phase shift, the signal is represented as such. And for symbol 0, that is phase shifted by 90 degrees, there will be a difference. So generation of BPSK. So to generate the BPSK signal, we shall consider that the figure which indicates the transmitter and receiver of BPSK signal. So first part A, which indicates the transmission or generation of BPSK signal. So first of all, the generator which has a non-return to zero level encoder as well as a product modulator. First, the binary data, that is symbol ones and zeros, are passed through the non-return to zero level encoder. So here the symbols ones and zeros are represented electrically, and the symbol 1 is indicated by one particular voltage, and symbol 0 is indicated by another voltage, and it is given to the product modulator. So the product modulator, it has the orthogonal base function, there is a carrier signal which is given as square root of 2 BTB cos 2 pi FCT. Now the message signal as well as these two signals are modulated and produces the output. The output will be the BPSK signal. So the product modulator, which multiplies the level encoded binary waveform and the carrier signal C of t, and produces the pulses of varying phase. So symbol 1 is generated by one particular phase of signal, and the symbol 0 is indicated by another one phase of signal. So both are shifted by 180 degree phase shift. So these BPSK signals are represented as antipodal signals because they have uniform in amplitude and frequency. The only difference is they are phase shifted by 180 degrees. Such signals are represented as antipodal signal. Next one is coherent detection of BPSK signal. So to detect the original binary sequence from ones and zeros, the BPSK signal X of t, the channel output, is applied to the receiver. So it consists of the product modulator. First thing which is product modulator has a carrier signal, so that is generated by the local oscillator. Thus the same carrier is used at the whatever the carrier we are used in the transmitting end, that is used in the receiving end. So it is named as coherent detection. And next is the low pass filter. So the low pass filter, that is used to remove the double frequency components of the product modulator output and passes the signals to the sampling circuit. So the sampler, so which uniformly samples the incoming signals. So at the periodical interval, the samples are collected, and that sampler is synchronized with the clock responsible for bit timing in the transmitter. Next, the sampled output is passed through the decision device. So this decision device which has a threshold value. So the threshold value is a preset value that is set within the system. And when the signal from the sampler circuit is given to the decision device, and the values of the incoming signal and the threshold is get compared, and if the signal amplitude is greater than the threshold value, the decision is made in favor of symbol 1, else the decision is made in favor of symbol 0. So the BPSK receiver is to be coherent because the sinusoidal reference signal, which is the carrier signal used in the product modulator of the transmitting end, is used in the receiving end. So the same signal with the same frequency as well as phase is used without any changes. Since both the transmitter and receiver uses the same carrier signal, the type of demonstration scheme is named as coherent detection. The operation of this coherent BPSK receiver shows the double sideband suppressed carrier modulated signals, and here the sampler and the decision devices are used. Next is the spectral analysis of BPSK. So here there's spectrum of this BPSK signal, so which is indicated as such. So here BPSK signal occupies a transmission bandwidth. So the bandwidth occupied by the system is 2 by TB, so which defines the width of the main lobe of the sync shape spectra. So this spectrum which includes the carrier component, whereas this component is absent for with the observation we can say that BPSK signal has bandwidth of 2 by TB, and spectrum is of bell shaped, and the signal is periodically sampled. Thank you.